Some of you have probably seen the video I made about the chinchilla light gene and the non-extension gene and how they work and how it applies to the shaded variety of Jersey Woollies. Well, I recently got this comment on the video, and when I saw it, I got excited because there are not a lot of people out there that know this much about rabbit color genetics. Just even research in general, there is not a lot that has been done on this specifically for rabbits. So, if I was wrong, I wanted to find out and I wanted to learn. So that's what I did. And it turns out what I said in the video wasn't exactly right. So I'm here to explain it. Now, this explanation is going to get a little long and it's going to be quite scientific. I'm going to try and put it as simple as possible because genetics is confusing. We all know quite a bit about how rabbit color genetics combine to make colors. If I breed X to Y, this is what I'm going to get. But as far as why those things do that, that's where it gets a little less clear, a little more foggy. So, that being said, let's get into it. So, first off, melanin. Melanin is the natural substance that is produced by our bodies that gives us color. There are two types of melanin. There is pheomelanin, which produces yellow and red pigments, and there is eumelanin, which produces black and brown pigments. I say our bodies because this applies to humans too. In fact, it applies to most animals out there. The next thing we're going to talk about is tyrosinase or tyrosinase. I'm not quite sure how it would be pronounced. But more scientifically, in rabbit breeding, what we would refer to as the C locus is actually known as the tyrosinase locus. Tyrosinase is a substance that is essential in the body's production of melanin. In more simplified, easy to understand terms, tyrosinase tells the body what pigments to produce and how to produce them. That's very simplified terms, very simplified. Now, when the C locus is in its most natural state, which would be your agouti, your wild type, this is what we would write down as being in the gene locus. This means that tyrosinase will be telling the cells to produce melanin in full force. No reduction. Produce the full amount, full color. You'll notice I'm talking a little slow because this is a lot for me to learn and squeeze into a video right now. So I'm trying to talk slowly and make sure I get everything out the right way. Now, let's say we have a rabbit that has the chinchilla light gene or the shaded gene. What this actually does is changes the amount of activity that the tyrosinase is doing. So the tyrosinase will reduce the amount of pigment that it is causing cells to produce. But for some reason, with the chinchilla light gene, it disproportionately affects pheomelanins. So those are your red pigments and your yellow pigments. So there will be a reduced amount of those produced. I'm going to read you a literal definition of what the chinchilla gene does. And I'm going to share this article on this site where I got this information from, because after trying to find it, this I think is one of the best that I have found. So if you want to learn more about it and get into the nitty-gritty of genetics, it might be worth a read for you. But the chinchilla gene, it significantly dilutes or eliminates red and yellow pigments while leaving black and brown pigments relatively intact, though they may appear slightly muted. In my original video, I said that what the chinchilla light gene does was turn off one of 4 yellow pigment cells. I think where the confusion arose with what I had read and learned was there are 4 there are 4 types of pigment, as I said earlier. There's the red, the yellow, the brown, and the black. And I think when I said it turned off one of the 4 yellow pigment, if I can say that. I messed it up in the original video too. It does not turn off the yellow pigment. It reduces the amount of red and yellow pigment being produced. Now, as I also said earlier, there's not a lot of research out there about this. And the only information I could find was of chinchilla genes in general. I could not find information comparing the chinchilla light gene with the chinchilla dark gene, which that is the gene responsible for actually producing the chinchilla color in Jersey woolies and other rabbits. Most of the research on this has actually been done on mice, so I was very happy to find some that had been done on rabbits. Now, again, there's not a lot of information out there, so if you know something different that I don't, I want to hear it, because I like this stuff. I'm interested and I'm excited to learn, and I hope you are too. And if you're not, I hope what I'm doing here gets you interested. And I hope we keep moving forward. Through failure, we learn. Through success, not so much. By the way, I took that from Meet the Robinsons, so credit to Disney, just so I'm not violating any copyrights.